Today in this video we are going to discuss about the strength of various materials. Normally for all type of constructions we are using various materials available in the universe such as steel, brick, aggregates, glass, concrete, cement, rubber, etc. But before using those materials, we must know about the strength of those materials, that is, whether they are capable to bear the load or not. For example, if we provide some information to a student, then how to know whether he has memorized something or not? Then the answer is test. By the help of test, we could able to know about the student's capability to memorize. If he or she has to memorize something, then how or what is the process of memorizing the information of that student, that is also very important. Like that, material's strength or capability to resist the load can be determined through test, and load transferring mechanism is also important within the material. For any type of test, we need to apply load on the material. Now there are 5 types of load that can be applied over the material, that is tension, compression, shear, bending and torsion. Now for example, all the student exhibits some unique property like a good artist, good behavior, good dancer, like that. All the materials also exhibits some property like hardness, brittleness, elasticity, plasticity, which are required to bear the load. So it is important to know by the test whether the material has more elasticity, plasticity or hardness, or less elasticity, plasticity or hardness. But before that, we should have proper definition of these properties so that we could get the result of the test for the determination of values of different properties as per our expectation. Now let us discuss about the different types of load, that is what is tension load, what is compression load, what is shear, what is bending and torsion. So first of all, we will discuss about the tension load. Tension load is the pulling load which elongates the material. Tensile load can be axial as shown in the figure, can be developed due to the bending also, and later on we will discuss how tension force is developing in the while applying the bending moment. So here in this figure we have shown about the axial tensile load. Now come to the compression load. Compression load is the pushing load which compresses the material or shortens the dimension of the material. Here we are discussing about the tension and compression load on a single plane only, not in other planes. So we are here discussing about the one-dimensional compression, when the compression force and tensile force will be discussed on all planes, then that will be called as three-dimensional analysis. You can see here, this is the example of three-dimensional analysis. Now come to the shear analysis. What is shear force? When tangential force will be imposed over any plane, then one of the plane of the material tends to slide over the another plane. Here you can see this is one plane and this is the other plane. This plane tends to slide over this plane. That is why, because of this tangential force is acting over this plane. That is why this is known as the shear. So shear is developing over this plane because of the application of shear of force over this plane. So the maximum shear force occurs at this top position, then shear force normally reduces, and at the bottom the shear force may be 0. Like that, due to the excessive compression also, shear is also developing in some plane within the material. Later on we will discuss how shear is developing here in this material, due to which this type of failure occurs in this material. But only you remember, shear force develops due to the tangential loads only. Here the shear plane of brick masonry for under various the quantity of mortar is shown. For better understanding of shear, I am going to show you the example of a landslide occurs in India. Here you can see the soil is sliding over the soil is sliding. Okay, one second. Here the soil is sliding over this surface. That is why this is the example of a shear failure. Now let us discuss about the bending. When transverse load applied on the material, then movement normally develops at the end position of the material. If the material is supported at the end position, then the material undergoes bending. This is known as the bending moment, or bending moment develops within the material. Or due to the application of transverse loading, movement develops at the end and the material bends from the center. Here you can see the animation how the material is bending. So this is nothing but the bending moment. We cannot say it is as a load, but here the bending occurs due to the movement only. That is why we can say this is a bending moment. So when here in this figure you can see this is the moment and this is the center point of the moment. So a axis which passes through the center point of the moment is the axis of the moment. So if the axis of the moment coincides with the longitudinal axis of the material, then that type of moment is known as the torsion. Later on we will discuss. But if the axis of the moment perpendiculars with the axis, longitudinal axis of the material, then in that case this is known as the bending. So bending can be occurs in Y or Z axis, but torsion can be occurred in X axis. Now here you can see the movement develops due to the application of, let us apply some transverse load. Due to the application of transverse loading, the moment develops within the at the end of the material. Here you can see when the axis of the moment coincides of the longitudinal axis or becomes parallel with the longitudinal axis of the material, then torsion develops or twisting develops. That means some portion where the moment is applying becomes twisted or bent in along the x direction. So this is nothing but the torsion. Here also you can see an example, one of the man trying to rotate in x direction of another man, of a hand of the another man. So here one man trying to bend the ruler or twist the ruler in x direction or along the longitudinal direction. So this is nothing but the torsion. Here the center of the moment becomes parallel or coincides with the center of the ruler. That is why this is nothing but the torsion. I hope you have understood the difference between the moment, bending moment and torsion. This will be helpful in the analysis of strength of material. Now, as I told you, here you can see how twisting occurs in the material. Now, previously I have discussed about the properties of the material, how the properties of the material plays a vital role for analyzing the strength of the material. As I told you, the material strength or capability to resist the load can be determined through test, and the load transferring mechanism is also important within the material, and this test can be well defined, or the value of the test as per our expectation can be well defined only after knowing the properties of the material. Actually, material has various properties like mechanical properties, thermal properties, optical properties, electrical properties, technological properties, chemical properties, magnetic properties and physical properties. But amongst all these properties, we have to study about the mechanical properties only, because in construction field this mechanical properties is also important, and we should have better knowledge regarding the mechanical properties. So what are the various mechanical properties? As here it is listed, you can see ductility, brittleness, malleability, toughness, hardness, fatigue and hardness are separate. Okay, here fatigue and hardness are separate things. Fatigue and hardness, creep, stress, relaxation. So here all these properties are the mechanical properties of the material. In this video we will discuss about the ductility and brittleness only. Later on we will discuss about the malleability, toughness, hardness, fatigue, creep and stress relaxation. So what is the ductility? So it is the ability of the material to undergo plastic deformation without failure. That means in ductile material, long deformation can be possible, and before failure of the material shows some signs of failure, that the material is going to fail. Like here you can see the ductility test of a bitumen. In this case, the material before failure shows some indications of failure. Here the material is going to be failed. How we could able to know? Because the material shows some sign that the dimension of the central portion is getting reduced. but which does not happens in case of brittle material. So in ductile material, as I told you, last deformations are possible in ductile material before the absolute value of rupture takes place. We can take some examples of ductile material like mild steel, aluminum, copper, manganese, lead, nickel, brass, bronze, monel metal, etc. are the various examples of ductile materials. Actually, there are two common measures of ductility. Now the question is how to measure the ductility of a material. There are two type of common measures, that is percentage elongation and percentage of reduction. So percentage of elongation can be calculated by the simple method, that is, after applying the load, what is the change in length. After knowing the change in length, we can compare it with the original length and we could get the percentage. And if maximum load was applied but the change in length was small, then the material is too much ductile. If the maximum load is applied but the percentage elongation is less, then the material is less ductile, we can say. Like that, percentage of reduction can be calculated when we apply some pushing forces. So what is the percentage of shorten of the material? That can also be found out. Later on we will discuss about this percentage reduction, percentage elongation, and we will do some numericals over that. The ductile material, the stress strain graph of the ductile material as shown in the red, this graph shown in the red color. The amount of ductility is an important factor when considering the forming operations such as rolling or extrusion. So ductility is also used a quality control measures to assess the level of impurities and proper processing of the material. So the ductile material shows the plastic stage before failure. As I told you, it shows some sign or indication before failure, which the brittle material does not show. Here you can see after reaching to the yield point, it just fails. But in case of ductile material, after reaching the yield point, it goes to this limit. That means it is showing that it can resist more load after going to the yield point. So what is ductile fracture? The fracture that occurs with plastic deformation and physical warning before fracture, that is necking formation. So most common fractures are moderately ductile. Here you can better understand here the steps of the ductile failure. You can see a material when the dimension of the material reduces, that is known as the necking formation, and after reducing, some spots are seen, that is void nucleation due to the application of excessive load. That means some cracks, small cracks will be seen, and that small cracks becomes more, and all the small cracks will mingle to form the large cracks. And after forming the large cracks, then the material gets failed. So this is the fracture, and this is the void coalescence. Okay. So shearing at the surface, this is the shear failure, and lastly it is get a fracture occurs in this stage. Okay. Okay, here you can see how ductile failure occurs. First the necking formation stage, then the fracture occurs, and within that period, as I discussed you, that is void nucleation and void coalescence occurs. Here you can see and you can imagine how ductile failures occurs. Next, come to the brittleness. What is brittleness? Here you can see how the brittle failures occurs. The materials does not show any sign of failure as in the ductile failure. It just fails. When it reaches the yield point or maximum stress limit, it just fails. You can see here. So brittleness is the lack of ductility. That is, material cannot be stressed. And brittle material failure takes place within a very relatively small deformation. And we do not require especially the brittle materials in our construction because it does not show any sign. For example, if you are living within a house and the house fails or the roof of the house collapses without showing any indication means if some materials fall or from the house before failure, that means cement comes out from the roof before failure, then you can imagine that the roof is going to fail and you can save your life. But if such thing does not happen, then that means that type of failure is brittle failure, and it may be very dangerous. It may take the life of various peoples, so it is undesirable. So for brittle materials, fracture point and ultimate points are same, and after proportional limit, very small strain was seen normally. As I discussed the stress strain graph of the brittle materials, here you can see the stress strain graph of the brittle materials. It has very less strain, whereas for ductile material the strain limit is very high. So some of the examples of the brittle materials are cast iron, concrete and glass. So in the brittle fracture, the original shape is, this is the original shape, and suddenly fracture occurs. Rejoining of the shape can possible in some cases, cannot be possible. Okay, after rejoining it has a tendency to fail again. So a little or no plastic deformation before fracture. So here it is a comparison here, ductile and brittle materials. The various examples of ductile materials are mild steel, aluminium, copper, brass, bronze, etc. Brittle materials are cast iron, concrete, glass, and it cannot be stressed, whereas ductile material can be stressed. And the post-elastic strain. After the elongation, the elastic strain is greater than 5%. As I told you, the strain of the ductile material is much more higher than the strain of the brittle material. Normally, we are taking the limit of 5%. If the 5% strain is more than 5%, then it is ductile material. If it is less than 5%, then it is brittle material. So normally the tension, it is weak in tension, the brittle material, and ductile material are weak in shear. And the failure type is the cup cone failure, whereas the brittle failure is normally the shear failure. We will discuss all these things later on. Just you remember the comparison. Cup cone failure I have shown here. This is the cup cone failure. Such type of failure occurs. So this is the cup cone failure. That means the material just here the material gets separated from each other like in this way. So this is nothing but the cup cone failure. And shear failure, it is if the brittle material was subjected to any load, then this type of failure occurs in material along this plane. Normally in this plane occurs. If it is a rectangular body, then this type of failure is known as the shear failure. And the cup cone failure normally is with 45 degree to the axis. Okay, and shear failure normally occurs with the 90 degree to the axis. here if the failure occurs like this, then it is 90 degree with the axis. Normally occurs this type of failure or this type of failure. It may be 45 degree. That does not mean that only the curve cone failure is 45 degree and brittle failure is 90 degree. So here it is also written. So the overall, this is the comparison in between the ductile and brittle material. So I hope you have understood the basic differences in between the ductile and brittle material. So in the next video we will discuss more about the other properties of the material. So thank you.